Hey everyone, welcome to Ladboy coding. Today we are going to solve problem 289, game of life. And this is a very common question in the interview. This is the question that do not test our algorithm skills, but it tests us on how to follow the instructions and how to handle edge cases very, very carefully. So let's read our question. The game of life is that given a board, each cell is either left or dead, and then based on these rules, each cell will interact with its neighbors. So we need to write a function to compute the next stage given the current state. So the next stage is created by applying these rules simultaneously to every cell in the current state. So yeah, there's nothing to okay, so before jumping to coding and follow all these rules, let's list our steps. First, we need to copy the board to store the initial state, because we cannot update the current state while iterate over it. Then for every cell, iterate over its neighbor and count the number of dead cell and number of live cell, and then we can make the change based on these rules. So basically these are two steps, but we have two more questions to cover. How to handle edge case. For example, if this is the board, then we start from a 0. 0 has 3 neighbors, right? It do not have 8 neighbors. But this cell, a 0, has 8 neighbors around him. So we need to handle all the edge cases in the boundary, right? This is how we handle it. We can first get the number of rows and also the number of column. Let's say the current index is I and j. So if I is larger than 0 and I is smaller than the length of the current row, and if the column is larger than 0 and column is smaller than the length of column, then it is a valid index. Otherwise, we can just assume that there is an additional dead cell around the current state. So for example, if this is a 0, then it has 5 dead cells. Yes. Okay, so this is how we handle the boundary. And if it is out of index, we can just assume there's a dead cell around the state. So yeah. Second question, how do we iterate over the neighbor? Okay, so if the current index is a 0, let's list all the neighbors. So this is 0, 1. This is 0, -1. And -1, 1. This is 1, 1. And then this is -1, -1. And this is 1, -1. All right. And then this is -1, 0. This is 1, 0. So this is the neighbor index. We can just create an array to store the neighbor index and then iterate over this array. So yes, so this is our algorithm. Now let's code it. This is how we deep copy a board. And we also have this neighbor array. So, and we also need to get the number of rows. Number of column. Then let's just follow the instruction for row in range rows, for columns in range columns, print board RC. So this will give us every value for every cell. Let's just run it. Yes, so we can see 0, 1, 0, 0, 0, 1, so on and so forth. So now let's have two numbers, life cell and dead cell. Then we just need to iterate over the neighbors. Neighbor R, and then we just need to iterate over the neighbors. So the neighbor R and neighbor C is our new index of the neighbor. Now we need to check if the index is out of boundary or not. Else, we increment our dead cell. If it is within the index, then if the initial state is equal to a 0, then we increment our dead cell. Otherwise, we increment our live cell. Then after the cycle, we can update the board based on the number of a live cell and dead cell. So let's print alive and dead. Yes. So for example, in this index, a 0, it has one live cell and 7 dead cells. So here, any live cell with fewer than 2 live neighbors dies. So we need to check it is a live cell. So this is the first rule. And then second rule. Any live cell with 2 or 3 neighbors lives to the next generation. We just need to do nothing. Any live cell with 3 neighbors dies. So yeah. And then any dead cell with exactly 3 live cell become alive again. And then we can just return the board. So yes, this is our algorithm. is correct. Let's submit our code. Yes. And for the time-space complexity analysis, the time complexity is indeed n times m. And the space complexity, if we copy the initial state, then it would be also n times m. Okay, thanks for watching. Bye bye.